In this video, we'll show you how you can get started with the TAO Toolkit. What is the NVIDIA TAO Toolkit, you ask? The NVIDIA TAO Toolkit, built on TensorFlow and PyTorch, is a CLI and Jupyter notebook-based solution that abstracts away the AI and deep learning framework complexity. The TAO Toolkit allows you to leverage the power of transfer learning to fine-tune NVIDIA pre-trained models with your own data. You can then deploy these models with DeepStream, Riva, or Triton Inference Server. The first step is to provision a system with the hardware requirements shown here. In the second step, we'll download and install the Docker environment. We'll also install the NVIDIA Container Toolkit and NVIDIA Docker, which will provide all the dependencies to run our TAO Toolkit container. We'll also set up an NGC account that makes it easy for us to pull the container with an API key. And finally, set up the Python virtual environment, which allows us to further isolate the TAO Toolkit from the host dependencies. In the next step, we'll download the sample Jupyter notebooks for computer vision. Please note that we also have several notebooks for natural language understanding and speech-based use cases as well. We'll then launch one of the sample notebooks to install the TAO Toolkit and set the environment variables. And finally, when we're done, we'll start training the model. So let's get started by installing the prerequisites. To get Docker running, simply type in the command shown. This will download all the necessary files to get Docker up and running on your host system. So what is Docker? Docker is an open source platform for building, deploying, and managing containerized applications. It makes it very easy for you to develop and deploy your applications on any infrastructure. Once Docker is installed, we will then need to download the NVIDIA Container Toolkit by entering the command, shown here. The NVIDIA Container Toolkit allows users to build and run GPU-accelerated containers. The toolkit includes a container runtime library and utilities to automatically configure containers to leverage NVIDIA GPUs. Then we'll install NVIDIA Docker. NVIDIA Docker is essentially a wrapper around the Docker command that provisions a container with the necessary components to execute code on the GPU. Once that is installed, restart Docker for the changes to take place. You can verify this by running the docker run command. The next step here is to get an API key from the NGC catalog. The NGC catalog is a GPU-optimized hub of AI and HPC software. Simply head over to ngc.nvidia.com. From there, click on Create a New Account and follow directions. Once you have registered, click on the Setup on the top right-hand from the pull-down menu. Then select Get API Key and then head over to Generate your own API key. Once the key is generated, you can copy the key and paste it back into the CLI window to log into the NGC Docker registry. After successfully logging in, we'll then install the virtual environment wrapper. Now that we're done with the prerequisites, let's download the computer vision Jupyter notebooks from the NGC catalog. You can see the list of notebooks we provide for all the computer vision use cases, from object detection to image segmentation and image classification supported in TAO. Start the virtual environment we created before, and then start the Jupyter notebook, which is essentially a development environment that provides interactive coding, faster analysis, inline markdown, amongst many other features. To launch the Jupyter notebook, copy and paste the URL shown into a web browser. Now select the DetectNet v2 to view the Jupyter notebook shown in the list. We'll first set up the environment to map the host data, project directory to the container directory. The toolkit can be installed simply with the Python pip command. Now, in this example, we will experiment with a simple kitty detection dataset. The cells shown in this prepared dataset section show the command and the pre-processing needed for downloading, unzipping, and verifying the data. The DetectNet v2 app requires the kitty formatted data to be converted to TF records for optimized iteration across the data batches. This conversion can be simply done with the Dataset Convert tool. Next, download the pre-trained model from NGC. As you're aware, we will be using the pre-trained DetectNet v2 model for fine-tuning. You can choose to train with the default specification, or you can change the spec file and define the model configurations, such as path to the downloaded model, type of model architecture, data augmentation, learning rate, and much more. You can find the sample spec files in the spec folder here. So now we're all set to trigger the training. You can simply use the TAO DetectNet v2 train command with the training arguments. Once the model has been trained, you can use the model prune feature to remove unwanted layers and neurons by simply setting the pruning threshold. You'll have to retrain the model, of course, to regain the accuracy lost during this process. Once you have retrained the model, you can export the model as is or export it in int8 format. For int8 optimization, the TAO Toolkit will generate a calibration tensor file. Once that is complete, you can then generate a TensorRT engine using the TAO converter command. And finally, you can verify the deployed model by running inference and visualizing the result within the Jupyter notebook. Alternatively, you have the option to enable quantization-aware training. This allows you to optimize the model to int8 format without sacrificing the accuracy. Please note that you'll have to retrain the model to induce quantization. After quantization-aware training is complete, and you are happy with the model and its performance, you can export it. Here, the model gets converted into a .etlt format that can then be easily deployed with NVIDIA's frameworks like DeepStream. Okay, now that our Jupyter notebook is all set up, let's run all these cells with just one click. The retrained and exported model is added to the model directory that we define when setting the environment variables at the very beginning. Similarly, you can see the model is generated after pruning and retraining. When the training is complete, we can do a quick inference check to verify the model performance and accuracy. Now, let's check how the retrained model performs on these sample test images. The green bounding box shows the detected cars, the red bounding box shows the detected person, and the cyan color bounding box shows the detected cyclist. So now you've seen how easy it is to get started with the TAO Toolkit. Head over to our Getting Started page and start training your first model.